Hey everyone, and welcome. Today, we're going to dive into one of Python's most powerful tools for repetition, the while loop. Seriously, if you've ever needed your code to do something over and over again, you are in the exact right place.
So let's kick things off with a classic programming puzzle. Picture this. You need to keep asking a user for input, or maybe you're running a simulation that stops when something happens. The key is you don't know ahead of time if it needs to run 5 times or 500. So how do you handle that kind of unknown?
Well, the answer is actually pretty slick, the while loop. You can think of it like a super focused employee. It looks at one single condition, and as long as that condition is true, it just keeps on working, executing that block of code. The very moment that condition becomes false, it stops. It's literally built for those moments when you just don't know how many times you need to go.
All right, talk is cheap, right? Let's actually build one from scratch. We're going to see exactly how all these little pieces click together to make a perfectly controlled loop.
Okay, first things first. Every loop has to start somewhere. We kick things off by creating a variable. We'll call it count and set its starting value to 1. This little variable is going to be the heart of our loop's condition.
All right, step 2. We give the loop its one and only rule. This line, while count c is less than or equal to 5, is the gatekeeper. Before every single trip through the loop, Python asks, hey, is the value of count less than or equal to 5? If the answer is yes, the gate swings open and the code inside gets to run. If it's a no, nope, gate's closed, the loop is done.
So what happens when the gate opens? Well, the indented code is our action block. First, we print out whatever the current value of count is. But that second line, oh man, this is the most important part. Count plus equals 1. This is absolutely 100% crucial. We are changing our variable inside the loop. If we forget this step, our condition never changes and, well, we'll get to what happens then.
So if you put it all together, the loop is doing this little 4-step dance over and over. Step 1, check the condition. Step 2, if it's true, run the code block. Step 3, update the counter. And step 4, go right back to the beginning and repeat. It's a simple, powerful cycle.
But what if that condition just never becomes false? This is where we hit the #1 pitfall, the thing that trips up almost everyone when they start out with while loops. It's a real program wrecker.
Yeah, it's called an infinite loop, and it's exactly what it sounds like. It happens when you forget that crucial update step, like our count plus equals 1. The condition, count less than or equal to 5, will always be true, so your program just gets stuck in this trance, spitting out count is 1 over and over and over again until you have to pull the plug.
All right, pop quiz time. Based on what we just talked about, what do we call it when that loop condition gets permanently stuck on true?
You got it. It's C, an infinite loop. It happens because the gatekeeper, that condition, never gets the signal to close the gate, so the code just runs and on forever.
Okay, so we know the big what not to do. Now let's get into one of the coolest things while loops are actually for, letting the user decide when to stop. We're going to build out our toolkit and really start mastering these things.
This technique is called a sentinel-controlled loop. Sounds fancy, but the idea is super simple. We just tell the loop to keep on running until the user types in a special word, a secret password, basically. We call that password the sentinel. Check this out. The program asks for a name, right? The user types in Abhi and hits enter. Since Abhi is definitely not our secret password, the loop's condition stays true, and it runs the code inside, printing, hello, Abhi. Then it just asks again.
Okay, but now the user types stop. Our loop's condition is probably something like while input does not equal stop. Well, now the input is stop, so the condition is now false, and boom, the loop just stops. Cleanly, no fuss. It's a fantastic way to hand the controls over to your user. But what if you need to be even more of a control freak with your loops? From the inside? Well, Python gives us 2 super powerful keywords for that: break and continue. Think of break as the big red emergency stop button. It gets you out of the loop immediately. Continue is different. It's more like hitting skip on a song. It just ends the current cycle and jumps straight to the top to start the next one.
All right, let's lock this in with another quick question. When your code is running along inside a loop and it hits the break keyword, what happens next?
And yep, the answer is D. It exits the loop immediately. It doesn't finish what it was doing, it doesn't check the condition again, it just bails. The loop is over, right then and there.
Okay, get ready for a serious pro tip.
This is a feature that, I kid you not, a lot of Python developers don't even know is a thing. It's the else block for a while loop, and it's pretty cool.
Now here's the trick, and you gotta listen close. The else block only runs if the loop finishes the way it was supposed to, by its main condition becoming false. If you cut the loop short with a break statement, Python completely skips the else block. It never runs.
I know, that one's a little weird. So let's put it to the test. When does that special else block on a loop actually get to execute its code?
That's right, it's C. It only runs if the loop finishes its entire job without being interrupted by a break. This is perfect for things like searching. You can loop through a list to find something, break when you find it, and then use the else block as your not found message. Super clean.
Wow, okay, we have covered a ton of ground here. We've gone from the absolute basics to having this really awesome toolkit for controlling exactly how and when our code repeats itself. Let's do a quick final review.
So let's run through our new toolkit one last time. We've got the basic while loop, our foundation. We can give users control with sentinel values. We have fine-grained control with break to exit immediately and continue to skip to the next round. And for our pro-level move, we've got the wild else block that runs only when a loop finishes naturally.
And that, my friends, is the Python while loop in a nutshell. And just like the great B.B. King said, what you've picked up today is yours to keep. The next time you're staring down a problem with an unknown number of steps, you'll know exactly which tool to reach for. So the real question is, what are you going to build with it?